Good day, everyone. Our topic for today would be network topologies, or we call it networking topologies. Here's your teacher for today, still Mr. June. And coming up, we are going to discuss about what is physical and logical topology and the different types of topologies. All right, as the main topic here is all about the networking topologies. Now, let's have a look on the terminology or this term about network topology. It is an arrangement of elements in a computer network. So if you try to take a look at this simple definition, we are going to take a look of what are these elements that is going to be arranged in the topology itself. And of course, yeah, the different topologies that we are going to discuss. Okay, networking topology. Well, there's a lot. Okay, each network topology has its own advantages and disadvantages, and of course, there are many new topologies now that are actually being used in the field of computer networking. And of course, those older topologies, okay, and of course, no longer being recommended as their use slowly being discontinued due to some disadvantages that is actually being encountered by network technicians or networking professionals, or whenever a kind of networking topology is going to be implemented in, let's say, in a building or in a school or a campus or university, and in any aspect. Yeah, computer networking is always being used whenever there is what we call a high-rise building or any industry that is going to be to be built. And definitely, yeah, we can see around there's a lot of networking topology that is being used nowadays. But in our key discussions for today, we are going to discuss on the most common networking topology as per coverage by our ASNA level, or the Cambridge Computer Science. All right. Before we start with the different topologies, let's take a look at some of these different terms that we need to look into for us to establish the basis and the foundation of what is this network topology, and eventually going to discussing the different types of topologies. So we have here logical topology, how elements are connected in principle, though of course there is a physical connection. Okay, though the physical connection may differ, how elements are connected in principle. So that's the meaning of logical topology. And when you talk about physical topology, how elements are actually, so if you try to take a look at this one, actually plug in together in reality. So this how the devices are actually going to be connected to one another. So that's what we call physical topology. And of course, yeah, let's have here a very good what goes on example. Let's take a look at this one. So there is actually two networks here. This is to give you an idea of what is this network topology, and of course, looking at the diagram itself, they have the same logical topology, although the networks are seem to be different in connection. Okay, if you try to take a look at network A, okay, there are two rooms here. There is an office, and then of course this is the living room. Okay, office and living room. And then let's say there is one computer in the living room, and in the office there's already a router here, and of course two workstations are connected. And as you notice on this simple diagram, they're connected through a wired connection. Okay, and then network B is just a living room, but you notice there is actually a wireless router here, and then other devices. Okay, maybe your laptop, your desktop computer is also equipped with wireless technology, and your iPad or your cell phones are connected to the wireless router here. Logically speaking, they are actually having the same logical topology. Okay, so if you try to take a look, they are actually connected to one source. Okay, or simply the router or the wireless router. So in principle, they have the same logical topology, only that they have a different physical network topology wherein network A is actually connected through a wired connection through wires, okay, or UTP, usually UTP. And then network B is also the connection is wireless. So that's the difference between these two network. Now, there are some terms here that we need also to look into it before checking on the different networking topologies. Number one here, guys, is that we have here network topologies. Okay, talking about data communication, of course. In one of my subjects before, yeah, I have what we call data communication. Of course, we need to look into discussion what are these networking topologies. Okay, there are 5 requirements for a data communication. Okay, so for this communication system would communicate to one another, or we simply call it as a communication system. There are many requirements. Okay, there should be a sender or receiver. What is this transmission medium? Of course, there is a message. Okay, and of course, a what type of protocol that's going to be used. A transmission can either be through air or Wi-Fi or cables. Okay, or for Ethernet, or we also using what we call the fiber optics. Okay, fiber optics cable, which is very popular nowadays. Data can be sent, so how data is being transmitted. Okay, this is actually considered as the different transmission modes. Okay, we have what we call the simplex mode, where data flows in one way only. Okay, and then half duplex, data can flow, or the data can be sent either way, in both directions, but not simultaneously. So I think this simplex, half duplex, and full duplex have been discussed in our in your IGCSE with regards to the different modes of transmission. And then full duplex, where simultaneous, or it's actually both ways data flow is possible. So in both directions, yeah, there is an exchange of data. Of course, a message is any type of data which can be sent as either a broadcast, which is one-to-all communication. So usually this is used in radio and television networks. And then we have here multicast. Okay, the multicast here is which is from one source to many destinations. So only one source, and then it will be multicasted, or it is considered as being broadcasted to many destinations. Next one is a unicast, which is one-to-one communication. So this is to give you some concepts behind different terminologies also, and some requirements in data communication. Now let's start with the first kind of network topology. This is what we call the point-to-point topology. Okay, as you can see from the drawing, okay, very simple network, a point-to-point. Two devices are connected to one another, where two end systems are connected by a dedicated network link. Okay, so of course, transmission, how the data will be transmitted here could either be simplex or duplex, and a message can only be unicast. Going back here, one-to-one communication. When you say one-to-one, that's also merely saying it is considered as point-to-point network topology, or point-to-point connection. So two devices only, and well, it could be considered as simplex or duplex. Simplex may considered as, if you go back here, one way only. So one can send, and then after the receiver, of course, need to wait until the message being received. Then the sender might become also the receiver later on, or the receiver would become the sender later on. So this is considered as one-way communication, point to point. The other thing is the other type of topology is, we call it the bus network topology. Okay, a bus topology has one link, but it is shared by a number of end systems, and is therefore described as a multi-point connection. There's no direct connection between any pairs of the end system. So let us consider this what we call this diagram here. This is a type of bus topology. If you notice here, Okay, they are just connected with one trunk, or you usually call this one as a backbone. Okay, a backbone cable, and then each workstations are connected to this backbone. And you notice there's no direct connection between any pair of the end systems here. So for example, this workstation doesn't have any connection with this workstation. They are just connected to a single bus, okay, or it's considered as a single coaxial trunk cable, okay. And a message must therefore be broadcast even though it might only be intended for one end system. So that's the only drawback when you send a message. If you have 100 workstations or 50 workstations connected to the one trunk, definitely, yeah, all the message, okay, or the single message will be broadcasted to all of these workstations, okay. So as you can see here, there is what we call a T connector used to connect the new node to the cable. Now the only thing here, although it mentioned here, the topology is very robust because a fault in an end system or in the link to it does not affect the use of network by the other system. Okay, so if this one workstation here, let's say, let's make use of another color here. If this one workstation here encounters an error, it will not affect the workstation here. It will not affect this, it will not affect this, and it will not affect this. So they are working independently. But the only drawback here is when the trunk cable here encountered an error or encountered a problem, then all of the workstations can no longer work. Alright, next would be, we call it as mesh topology, and it's a fully connected mesh. It's actually what we call, so there are two types actually for this mesh network or mesh topology. We have what we call routing and flooding. Let's take a look at the difference of routing. Routing works by giving the nodes routing logic, or in other words, they act like a router. So of course, yeah, we know what this a router is. Whenever you send a message to computer 1, example only, then it will just send to the computer 1. It will no longer broadcast to any computers that is attached on the system. So from the word on routing, okay, so that the data, okay, as mentioned here, is directed to its destination by the shortest route and can be rerouted if one of the nodes in the route has failed. So that's what we call the routing mesh topology. The other thing is flooding, simply sends the data via all the nodes and uses no routing logic. So constantly whenever there is a message, then it will be flooded to all workstations or clients, okay, although it's only intended to one computer, so it will simply send the data to all the nodes, okay. Mesh topology is most used in an ad hoc networks or home networks. This is also specific, there is no specific structure, and all nodes can connect, okay, directly together or indirectly through other nodes. So we have what we call the small office, home office usually, yeah. Some of the connections here, the ad hoc connection. So you can just connect to the wireless router, and then one device can connect to the other router. One device is connected to the same router, or there are some instances that the device could act as a router in itself, wherein other devices can also can be connected. Alright, the next one is star or network topology. This is one of the famous, yeah, one of the mostly commonly used, okay, or most commonly used network topology. It uses a central hub here or switch, and each computer device is connected to the hub or switch, okay. Or nowadays we are using what we call routers already equipped with the wireless capability. So it's a router, okay. Data going from host to host is directed through a central hub or switch. Then each computer okay, or device has its own dedicated connection to the central node, hub, or switch. Any type of network cable can be used for the connections. Then type of networks, typically a client server. So from here, as you can see here, this is a very familiar connection to you. There is a server here, and then there are clients that are actually or workstations connected to the server. So if you notice, we call that one as a star topology because the connection of all of the clients here are actually dedicated on this server. Okay, the other what you call this one the other diagram here is that you notice there is a let me enlarge it for you. So you notice there's a hub here, and then instead of directly clients are connected to workstations, another hub is also being connected here. Okay, so most probably this is the main hub, and then if you want to extend, so this is one way, yeah, when we keep on extending our network. Okay, and then we connect it to the main hub, and then from the main hub, instead of the directly connecting the workstation or computer, you might connect another switch or hub, and then from that secondary switch or hub you can actually create another network. So as you can take a look at this one, there were three sub networks that was created. Okay, so it's not only a direct connection from the workstation itself, but you can also connect multiple devices. Okay, routers or switch or hub, as mentioned in the what you call this one, the definition of a network topology is how is the arrangement of these elements. So the elements there is not only limited to the computers, not only limited to the laptops or whatever devices that is connected to a central hub or a central switch, but it could also be another switch or hub, or more so, a wireless router. And of course, yeah, just like we are having what we call hybrid class, okay, we have this what we call hybrid topology also. So it is actually adapted to the particular needs of a network. So nowadays, there are some systems wherein it is a wired connection, but there is already the inclusion of wireless connection. Okay, so usually wireless router are being used now. So there are some considered as the central hub or central switch. They have actually being considered as I mean, when you extend the network, you can actually connect a wireless router to the central hub, okay, or your main connection, and that would be considered as, you know, another kind of networking topology. So we have here the first diagram here is that there is a switch, then two workstations was connected, and then from here it extended the network probably, and it created what we call a ring topology here. Okay, ring topology. From this next diagram here, so from one hub here in which it was actually it's a kind of a actually it's a star topology, and then from the hub there is another connection, and it created what we call a bus topology here. Okay, so that is considered as the bus topology. It's very obvious because there is what we call a single trunk. Okay, and then of course the computer, there is a connection there, so probably there is a internet connection. You want to connect to this network, okay, to this one computer, and then probably this this section here, it was created in such a way that it will give a connection also to the others. And then for the connection, okay, the type of topology that was used here is considered as bus topology. And of course the last one here is there is what we call a ring topology here. Nowadays ring topology is no longer used, so usually star topology, and then of course mesh, and then hybrid topology. Alright, so if you notice, that's a combination, yeah, combination of different topologies. So that's what we call hybrid topology. And that ends our discussion about different topologies. Thank you very much.